current slides, we will be studying about the naming of haloalkenes and haloarenes. So, in the examples given below, the first example is CH3, CH2, CH2Br. The common name is N-propyl bromide. That is a normal linear chain of an alkane where one hydrogen is replaced by a halogen molecule, that is bromide, and hence the common name is N-propyl bromide, whereas the IUPAC name is 1-bromopropane. Since it has 3 carbon atoms, the root word is prop, and it is a saturated molecule, hence propane. 3 carbon containing compound prop, a saturated compound, it is propane, and bromine is present on the first carbon atom, and hence the IUPAC name is 1-bromopropane. In the second example, that is CH3, CHCl, CH3. The common name is isopropyl chloride is the common name. Iso means it's for branching, and one of the hydrogen atom is replaced by a halogen molecule. The halogen molecule is chloride, hence isopropyl chloride, and the IUPAC name is 2-chloropropane. This compound also has 3 carbon atoms. This compound also has 3 carbon atoms, and the halogen atom, that is chlorine, is present on the second carbon atom, and hence the IUPAC name is 2-chloropropane. In the third example, it is CH3, CH, CH3, CH2Cl. It is isobutyl chloride. So it has 4 carbon atom, hence it is butyl. Iso is for branching, and therefore the compound is isobutyl chloride. The IUPAC name is 1-chloro-2-methyl propane. The carbon carrying the halogen atom is given more preference, and hence the naming is done from left to right. So it is 1, 2, 3. The first carbon atom is carrying the halogen atom chlorine, and the second carbon atom is carrying a methyl group, that is CH3 methyl group. And in a long straight continuous chain, only 3 carbons are linked, and therefore it is a propane. In the next example, we have a benzene ring, and one of the hydrogen atom is replaced by bromine. The common name is bromobenzene, and the IUPAC name is bromobenzene. In the next example, benzene ring has 2 bromine atoms. 2 hydrogens are replaced by 2 bromine, that is 2 halogen atoms, and the halogen atom is present on the meta position, and hence the common name is meta dibromobenzene, and the IUPAC name is 1,3-dibromobenzene. In the next example, we have a benzene ring where 3 hydrogen atoms are replaced by 3 halogen atoms. Here it is bromine. This is tribromobenzene, that is 1,3,5 tribromobenzene. The next compound is CH3C, CH3 at the top and CH3 at the bottom, CH2 and Cl. So the naming has to be done from the carbon atom which carries the halogen. Halogens have more preference when compared to a methyl, that is CH3 or CH2 group. So it is 1-chloro 2,2-dimethyl propane. The next example is 2-bromopropane. Three carbon atoms linked in a chain, and the second carbon atom is carrying the bromide molecule. Therefore, this name is now 2-bromopropane, and this is also an example for secondary halogen, because the carbon exists in 2 degree, or we find one carbon atom is attached to two carbon atoms, that is a secondary carbon atom. So in the next slide we have this example CH3C CHCl2. The common name is ethylene chloride. Ethylene chloride, or it is also called as a geminal dihalide. Geminal, Geminal, geminal dihalide. So here we find the first carbon, that is to the right, the first carbon has two chlorine atoms. I mean to say, both the chlorine atoms are attached to the same carbon atom, or both the chlorine atoms are joined to only one carbon atom. Such compounds are commonly called as geminal halides. And this is an example for a dihalide, since two halogen atoms are present on a single carbon atom. In the other example we have, it is ethylene dichloride. It is ethylene dichloride, commonly called as vicinal halides. VICINAL, vicinal halides, where we find two chlorine atoms or two halogen atoms are attached to two different carbon atoms. I repeat, two halogen atoms are attached to two different carbon atoms. Thus, they are called as vicinal. Vicinal means next to next in the common naming system. But the IUPAC naming is 1,1-dichloroethane, and the other one is 1,2-dichloroethane. Then we have the next slide. So here you will have to draw the structures of all the isomers, possible isomers of the compound which has a molecular formula C5H11Br. C5H11Br, that is bromopentane. So the possible 8 isomeric structures are possible for this particular compound, and name the each isomer according to IUPAC system, and classify them as primary, secondary, or tertiary bromide. So I repeat, so there are 8 isomeric structures possible for this bromopentane C5H11Br, and you will have to name them according to the IUPAC system and classify them as primary, secondary, or tertiary bromide. I'll get back with solutions in my further PPTs. And the next one is write the IUPAC names of the following structures given below. So in the next slide, we have this bond length, bond enthalpy, and the dipole momentum of a primary carbon, secondary carbon, tertiary carbon, and a quaternary carbon atoms. So primary carbon is which has only one carbon atom, So the bond is CH3 F fluoride, and the fluoride, the distance between carbon and fluorine, that is the distance between the centers of carbon and fluorine, is found to be 139 picometers, and the energy, bond energy, is 452 kilojoules per mole, and the dipole momentum is found to be 1.847 dBs. CH3Cl, the bond length is 178, the bond enthalpy is 351, and the dipole momentum is 1.860. CH3Br, the bond length is 193 picometers, bond enthalpy is 293, and the dipole momentum is 1.830. And the last one, CH3I, that is methyl iodide, the bond length is 214, the bond enthalpy is 234 kilojoules per mole, and dipole momentum is 1.636. So here we find in the carbon and halogen bond, that is the bond formed between carbon and halogen, we find halogen always develops a partial negative charge and carbon always develops a partial positive charge. This is due to the a difference in electronegativity. This is due to the difference in electronegativity. So halogens have 7 electrons in their outermost shell, and the one electron is being shared from carbon, and therefore the electron from carbon slightly moves towards the more denser halogens. Thereby, carbon develops a partial positive charge, and this effect is known as the polarizing effect or polarization effect. That is an anion. So, anion is a negatively charged species. So, the shared pair of electron, if it is pulled more, I repeat, the shared pair of electrons, so the electron that is shared between carbon and halogen, and this shared pair of electrons, if they are pulled by an anion like halogen, the electrons move more towards the halogen, and this pulling ability or drawing ability of an anion is known as the polarization effect. And this table tells us that fluorine is small, and therefore the bond length is also very small as 139 picometers. Chlorine is much larger, bromine even more larger, and iodine is the largest. And the bond energy therefore decreases. So if the bond length is small, we need more energy to break since the electrons are closer to the nucleus. Now, if electrons are moving away from the nucleus, that is from the nuclear forces of attraction, it is easy to break that particular bond since they do not fall under the attraction of nuclear forces, and therefore the dipole momentum also decreases. Higher the distance, sorry, larger the distance, more will be less will be the bond enthalpy, and lesser will be the dipole momentum. So in the next slide, we will study about the preparations of these haloalkenes and haloarenes, the methods, different methods which are named after the scientist who had prepared them for the first time, the reactions, the mechanisms, and more specifically the uses of these particular compounds in our daily life.